Settle in and let your breathing slow, because tonight, the loudest thing on earth is something you cannot hear. You think the coastline is still, solid, finished, but under the dark water, far offshore, the planet is doing its quiet work. One slab of crust sliding beneath another, like a long, patient sigh. In this kind of darkness, the ocean keeps its secrets well. No flashing lights, no drama, just pressure, heat, and time, stacking changes so slowly, they feel like peace. And if you stay here with the Sleepless Geographer for a while, you will drift from the Pacific edge into the hidden mechanics of subduction and into the Andes, a mountain range built in near silence. You are standing where the land meets the Pacific, and you can pretend it is a clean line, a polite border, water here, rock there. But the truth is messier and much calmer than it deserves to be. Out beyond the breaking waves, the seafloor is not resting. It is traveling, inching, sliding, arriving. A wide slab of oceanic crust is moving towards South America, night and day, without celebration. And when it reaches the continent, it does not stop. It bends, it dips, and it dives beneath the edge of the land. This is subduction, a simple word for a patient act of surrender. One plate goes down, the other stays up, and the surface life carries on, making dinner, building roads, naming towns, pretending the ground is a trustworthy thing. You think you are listening to a story about mountains, but mountain stories begin out here in deep water, where the first chapters are written in pressure. The ocean hides the boundaries so well that you could sail right over it and never know you crossed into the machinery. If you could peel the sea away just for a moment, you would see a broad trench carved into the seafloor. Not a dramatic canyon with cliffs you can admire, more like a long crease in the planet's skin. A place where the crust is being pulled downward, as if someone has taken the edge of a rug and begun to slide it under a door. The coastline itself may look still. Sometimes it even looks peaceful, but the stillness is a performance, because the plates do not glide smoothly like ice on ice. They lock, they snag, they grip each other with rough stone teeth. And while they are stuck, the moving plate keeps trying to go forward. So stress builds, slowly, in the dark. It builds the way dust builds in a quiet house. You do not notice it until you finally run your finger along a shelf. Then, eventually, the locked edge slips, the coast jerks, the sea floor flexes, and the ocean, which was only pretending to be calm, suddenly remembers it has weight. That is when earthquakes happen here, not as punishment, not as drama, but as adjustment. The planet rearranging its posture. And when the seafloor moves, the water above it moves too, not because the ocean is angry, but because gravity is obedient. A sudden lift of the seabed can send a long wave outward, quiet at first, then enormous. It is strange how the greatest violence can begin without noise. Down at the boundary, there is no roaring soundtrack, just rock grinding against rock in a place you will never see. And as the sea keeps its secret, your attention drifts inland, toward the first gentle rise of land that will, over time, become something enormous. You move away from the beach, and the air changes almost without permission. Salt softens, then fades. The land begins to tilt upward, so gradually you might blame your tired legs instead of geology. This is the slow dive beneath the continent, the part where the simple idea becomes a long process. One plate sinks, the other rides above it, and if you could follow the sinking plate down, you would feel the temperature climb in a steady, indifferent way. Oceanic crust is born hot at mid-ocean ridges, then cools as it travels. By the time it reaches this coast, it is old, dense, and heavy. It has been collecting water for a long time. Not water in puddles, not water in bottles, but water tucked into cracks, trapped in minerals, carried down like contraband. Seawater seeps into the crust through fractures and faults. It reacts with the rock, changing it, storing water inside new mineral structures. So when the plate bends and starts to descend, it is not just rock going down. It is rock carrying a hidden cargo of water into the deep earth. And this matters because deep down, water is not soothing. Water is a troublemaker. As the sinking slab goes deeper, pressure rises, heat rises. The minerals that were stable near the seafloor become unstable down here. They begin to break down, and when they do, they release their water. Imagine a sponge being slowly squeezed in the dark, not with hands, but with the weight of continents. Water leaks out, not in a gush, but in chemical whispers. That released water rises into the hot mantle above the sinking plate. The mantle is solid rock, but it can flow slowly over long time. And the water changes the rules of melting. Dry rock needs higher heat to melt. Add water, and the melting point drops. It is like adding soap to a stubborn stain. Suddenly, the same effort gets you more movement. So above the sinking slab, some of the mantle begins to melt. Just a little. Not a vast ocean of liquid, more like pockets, beads, and streaks of melt forming within mostly solid stone. This is the quiet beginning of magma. You do not see it. You do not hear it. But it rises anyway because it is buoyant compared to the surrounding rock, like warm air finding its way upward through a cold room. The melt collects. It moves through cracks. It stalls. It cools. It rises again. Sometimes it never reaches the surface. It freezes underground, becoming new rock inside the crust. A hidden architecture of intrusions, layered and stitched into the continent. But sometimes it finds a path, and that is when volcanoes begin. Not with an eruption, with a rout, a slow, persistent plumbing problem inside the earth. It is tempting to imagine the sinking plate as a clean slide into the mantle, a smooth ramp, but it is not smooth. It bends and fractures, it scrapes, it drags pieces of sediment down with it. Those sediments matter too. They are the dust and mud of ancient oceans, scraped off the seafloor like crumbs from a table. They get pulled down, heated, altered, adding their own chemistry to the melt. So the magma that forms here is not a pure thing. It is a mixture, a complicated broth made from mantle rock, oceanic crust, and buried ocean mud, which is a good summary of Earth. Honestly, everything important is a mixture of older things, recycled under pressure. The subduction zone does not hurry. It does not have deadlines. The conveyor belt keeps moving whether anyone is awake to notice it, and if you stay with it long enough, you can almost sense how a coastline becomes a mountain range. Not by magic, by repetition. A little melt rises, a little rock deforms, a little crust thickens, and then it happens again and again and again. And with that hidden melt rising upward, you can follow it like warmth through stone toward the long spine of volcanoes that outlines the Andes. Now you are far enough inland that the world begins to change its posture. The horizon breaks into shapes. Ridges appear like long backs of sleeping animals, and above them, the air carries a different kind of cold, a clean, thin cold that feels untouched. The Andes are not a single mountain. They are a system, a long stitched seam where the continent has been worked over for millions of years. You can think of the volcanic arc like a line of vents above the sinking slab. Not perfectly straight, not perfectly even, but persistent. Some peaks smoke, some do not. Most simply wait, looking harmless, like they are only scenery. Congratulations! You have found one of Earth's most patient forms of danger, a volcano that looks like a mountain because it is a mountain built out of its own past. Volcanoes here often build themselves layer by layer. Ash falls, settles, and compacts. Lava flows, cools, and hardens. More ash, more lava, time stacking materials like tired hands stacking blankets. And the materials are not soft, they are sharp, gritty, heavy. Volcanic ash is not like fireplace ash. It is pulverized rock and glass, ground fine enough to ride the wind and scrape your lungs if you breathe too much of it. When it rains on fresh ash, the story gets uglier. The water does not soak in easily. Instead, it grabs the loose volcanic debris and turns it into moving concrete. Mud flows, lahars, thick, fast rivers of ash and rock that follow valleys downhill. They do not need flames. They do not need explosions. They only need gravity and a sudden supply of water. So even the quieter phases of volcanism have consequences. A volcano can be sleeping and still be a problem because its old deposits are waiting for the right storm. But the Andes are not only volcanic cones. There are long ridges of uplifted rock, folded layers, broken blocks. There are places where the mountains look like crumpled paper and places where they look like walls. And the line of volcanoes is not continuous. There are gaps, stretches where the slab angle changes or where the system behaves differently. Subduction is not a perfect machine. It is a messy one. If you travel along the Andes in your mind, north to south, the climate shifts under you. Cloud forests in the north, damp and green, high cold plateaus in the middle. Farther south, winds and glaciers, and mountains that feel more like weather than rock. But all of it ties back to that quiet dive offshore. The plate goes down, water rises, melt forms, volcanoes build, and the continent slowly grows a spine. You might expect volcanoes to be the main architects here. They do add material, yes. They create new rock on the surface. They thicken the crust. They reshape the skyline. But volcanoes are only part of the story because the tallest mountains aren't just piled up. They're also pushed up. To understand the pushing, you have to imagine the edge of a continent as something that can be squeezed, not like a rigid block, more like a thick, stubborn carpet As the oceanic plate presses in and dives beneath, it drags against the underside of the continent. It transfers stress, and the continental crust responds by shortening. Shortening is a gentle word. It means the land is being compressed, the way fabric wrinkles when you shove it. Except the fabric is rock, and the shove lasts millions of years. Layers buckle into folds. Faults break and stack slices of crust on top of each other, a process called thrust faulting, which is exactly what it sounds like, one slab of rock being pushed up and over another. The crust thickens, and when crust thickens, it tends to rise, because thick crust is more buoyant. It floats higher on the mantle, like a thicker piece of wood floating higher in water. This is isostasy, a word that sounds like it belongs in an old textbook, smelling faintly of dust. But the idea is simple in human terms. If you load the crust, it sinks. If you unload it, it rebounds. And if you thicken it, it stands taller. So the Andes rise not because of one dramatic event, but because of countless small deformations, adding up. A mountain range made from stubbornness. And earthquakes, those sudden, sharp moments, are the brief times you feel that slow pressure adjusting itself. Most of the time, the motion is too slow to notice, but sometimes the crust slips along a fault. The stored strain releases. The ground shakes. It is the planet cracking its knuckles. The shaking is fast, but the cause is slow. That is the strange mismatch of subduction zones. The danger arrives in seconds, but the story builds over ages. As the Andes rise, the air changes, not only because you are higher, because the mountains themselves reshape the atmosphere. Wind hits the range and is forced upward. Air cools as it rises. Moisture condenses. Clouds form where the land tells them to. On one side, rain can be generous. On the other, the same range can cast a dry shadow. And up high, the light feels different, sharper, less filtered. You can feel the thinness in your chest if you imagine it closely enough. Not panic, just a gentle insistence from your lungs that they would like more oxygen than they are getting. The Andes make a rooftop of a continent, a cold spine that changes weather, water, and life for thousands of miles. And yet, for all their presence, they are still being worked on, because as soon as rock rises into air, it becomes a target. And once the land is lifted into the sky, the wind and water arrive to begin their quieter work, wearing it down, grain by grain. Erosion is not dramatic most of the time. It does not roar like an eruption. It does not shake like an earthquake. It simply continues. Rain falls, and it does what rain always does. It finds the lowest path. It gathers in tiny threads, then in creeks, then in rivers. And rivers, those calm-looking ribbons, are demolition crews with good public relations. They carry sediment away from the heights. They cut valleys deeper. They undercut slopes until gravity takes over and the mountain sheds a piece of itself in a landslide. If you stand near a steep Andean valley in the rainy season, you might hear it. Not the river itself, but the rocks. A quiet clacking and tumbling, the sound of stone being moved without permission. Higher up, where temperatures stay low, snow compacts into ice. Ice begins to flow slowly under its own weight. A glacier is not a static thing. It creeps. It presses into rock. It plucks and grinds like sandpaper with infinite patience. It carves valleys with a different signature than rivers do. Rivers tend to make sharp, narrow V-shapes. Glaciers tend to widen and round, sculpting U-shaped valleys and polished basins. So the Andes are shaped by two opposite jobs happening at the same time. Uplift pushes the land up, erosion pulls it down. It is like breathing, except the breath takes 1,000,000 years, and the material that erosion removes does not vanish. It travels. A grain of sand begins as part of a mountain. It is broken loose by frost cracking, by chemical weathering, by the pry of roots, by the simple stress of gravity. Then it falls into a stream. It bounces and rolls downstream, hitting other grains, becoming rounder, smaller, more obedient. Sediment is a traveling story, a record of what the mountains are made of, carried outward into basins and plains. Some of it will end up on the ocean floor again. Some of it will become rock again, pressed into layers. Some of it, eventually, will be dragged back down a subduction zone to restart the cycle in a deeper form. But for now, you can follow it. You can drift with the silt and sand as it leaves the high ridges behind, moving into wider spaces where the mountains still dominate the sky, but no longer press against your shoulders. Follow that drifting sediment, and you leave the heights behind, arriving in wide spaces where the Andes cast long shadows, places shaped by dryness as much as by rock. Here, the slopes loosen their grip on you, and the world spreads out. You are in the wide country that sits between ridges, where the mountains stop being walls and start being weather. The ground is flatter, but not soft. It is dust over gravel, and gravel over older stories. You think a plateau is a break from geology, a calm chapter. Wrong. This is just where the forces get better at hiding, because this broad, high space is not empty. It is a basin, a quiet bowl held up in the sky by surrounding rock. And when the Andes rise, they do not rise neatly. They rise in pieces, leaving pockets behind, places where sediment can collect and water can get confused. The air up here feels thin in a way that is hard to describe politely. Each breath works. It just does not feel like a full payment. The sun looks close, almost personal. The shade is sharp, and the night arrives fast. During the day, the surface warms quickly. At night, the heat escapes just as quickly. That daily swing, warm then cold, is a kind of slow hammer. Rock expands, rock contracts, tiny cracks widen, and the plateau manufactures its own grit. And the horizon, it does something strange at altitude. It looks too far away, not because the planet changed, but because your sense of distance is spoiled by clear air. Less haze means fewer clues, so everything feels closer, then farther, then wrong again. This is the kind of place where you can watch weather arrive like a visitor. A cloud builds over one ridge, drifts across the basin, and dissolves like it changed its mind. Rain can fall in a narrow stripe you can see from miles away and miss you entirely with an almost deliberate cruelty. Congratulations, you are living inside a balancing act, high enough to be cold, dry enough to preserve, and exposed enough to be sandblasted. Now, look down at the ground you are standing on. It is not bedrock pride. It is often a deep stack of basin fill, layers of sand, silt, gravel, ash, and salts, material that eroded off nearby ranges, then settled here, slowly, the way dust settles in an abandoned room. In places, ancient lakes used to sit in these bowls. Not the postcard kind, more like wide, shallow, stubborn pools. They expanded when the climate was wetter, then shrank when it dried, over and over. Each time water spreads out over a closed basin, it carries dissolved minerals with it. And when that water evaporates, it leaves those minerals behind. Again and again and again. That is how you get salt flats. Not because someone poured salt on the earth, because water arrived, did its chemistry, then vanished. You can picture it at dusk, a flat, pale surface stretching until it meets the feet of distant mountains. The salt crust can look smooth from far away, but up close, it breaks into geometric plates. Crunchy and fragile. Under that crust, brine can hide, cold and heavy, holding elements that humans get oddly desperate about. Lithium, for example, a metal that makes modern life feel portable. The kind of thing people dig for with serious faces in places that make every machine run tired. Up here, extraction is not heroic. It is logistical. Pumps, ponds, evaporation, waiting. A long industrial sigh under a big sky. And the plateau does not make waiting easy. Equipment corrodes, workers get headaches, fuel burns differently, and every task feels like it takes one more step than it should. Even boiling water is strange at altitude. It boils sooner at a lower temperature, like it is impatient, and yet it cooks food more slowly, like it is lazy. You are surrounded by peaks that helped create this place, and those same peaks keep feeding it. Every storm that hits a ridge sends little fans of sediment outward, alluvial fans they call them, a technical term that means the mountain has been shedding again. Sometimes you can see the fans clearly from above. They spill out of narrow valleys, spreading like a hand opening. Coarse gravel drops first, near the mouth. Finer sand reaches farther. Silt drifts to the flattest parts and settles there, quietly, like flour. It is a gentle kind of sorting, but it comes from violence. Flash floods, debris flows, sudden meltwater, and gravity that never takes a day off. And in between those events, the plateau sits in silence, a silence that is not peaceful so much as indifferent. The land is not comforting you. It is simply continuing. If you keep moving across this high country, you start to notice how life adapts by becoming small and stubborn. Tufts of tough grass that grow low, hugging warmth close to the ground. Shrubs that look half dead until they bloom after a rare rain. Animals that treat oxygen like a scarce commodity and use it carefully. You might see a vicuña, delicate and watchful, built for thin air, or a llama, looking mildly offended by everything, as if altitude is a personal insult. Birds circle on thermals, using the sun to do the work their muscles would rather avoid. And then there are the people, because of course there are. Humans have an impressive ability to move into difficult places and then act surprised when they are difficult. High towns exist here because roots exist here, because valleys offer water and passes offer connection, because the plateau is not just a void, it is a corridor between worlds if you know where to step. But the ground under those towns is not always stable. It is layered sediment, sometimes loose, sometimes saturated, sometimes salty, sometimes compacted. When an earthquake shakes this region, the shaking does not stay polite. Soft sediments can amplify it, wobbling more than solid rock would. And the water, when it does exist, can behave badly. In some basins, groundwater is rich in minerals. Not always the friendly kind. Arsenic can appear naturally, leached from volcanic rocks. You do not taste it at first. You just live with it until someone finally measures and everyone pretends to be shocked. Up here, even the lakes can trick you. Some are freshwater and alive. Others are hypersaline, heavy with dissolved salts, strange colors under harsh light. Green, milky blue, rust red. Not because the water is magical, but because microbes and minerals are doing their quiet work. In the morning cold, the edges of shallow lakes can freeze, a thin skin of ice that cracks under the first sun. In the afternoon wind, dust can skate across the surface, and by evening, the temperature drops again, as if the day was a rumor. You start to understand why the plateau feels like a pause. Not because nothing happens, but because what happens is so slow, so spread out, that your usual sense of time cannot grab it. This is geology that makes you smaller, not by threatening you, but by refusing to acknowledge you. And the plateau is not just high because it was lifted. It is high because it stayed high. When a region's crust thickens, it floats higher, like a block of wood in water. But it also resists being eroded away quickly, because the mountains feeding it keep rising, and the basin keeps catching what falls. It is a strange partnership. Uplift creates relief. Erosion destroys relief. Sedimentation fills the low spots, and the whole system shuffles mass around like furniture in a house nobody owns. Some basins here have no easy outlet to the sea. They are endorheic basins, closed drainage, water that arrives but does not leave as a river, so it can only leave as vapor. That means salts accumulate, and the landscape gets wider, flatter, and more chemically intense with time. If you have ever left a mug unwashed and watched a crust form, it is that scaled up to a continent and granted several million years of patience. And speaking of patience, the air itself is working on you, and the rock, wind on a plateau, is not a breeze. It is a long, steady administrative force. It lifts fine particles and carries them until they hit something. A boulder gets sandblasted on one side. A ridge develops a sharp edge. A small stone slowly grows a polished face, then a second face, then a third, until it becomes a ventifact, a rock carved by wind like an unwanted sculpture. The wind also builds. It piles sand into dunes in places where there is enough loose material and a steady direction. Some dunes creep a little each year, migrating like slow animals, rearranging the ground without urgency. In certain seasons, dust storms can rise. The world turns beige. The mountains fade. The sky loses depth, and everything feels close and far at the same time. And then, hours later, it clears, as if nothing happened, as if the land did not just move itself across your face. The plateau teaches you something subtle, not the dramatic lesson of an eruption or an earthquake, a quieter truth. Elevation is not just height, it is a climate machine. High land creates cold. Cold changes water. Water changes rock. Rock changes where life can exist. You are not simply walking across scenery. You are walking across a set of rules, and if you drift toward the western side of this high country, you feel the rules changing again. The air cools as it sinks. The sky clears. Clouds become less generous. The Andes, behind you and beside you, have been stealing moisture from winds that try to cross them. They wring water out of air like a towel. And what is left on the far side is dry. Dry in a way that feels deliberate. The descent is gradual at first. The ground tilts and the basin gives way to slopes. And the slopes give way to broken foothills. The mountains still loom, but now they are a barrier, not a backdrop. You notice something almost offensive. You are moving toward an ocean, and yet the air does not smell wetter. There are places on Earth where the sea is right there, breathing salt into the wind, and the land is still thirsty. A desert beside a shoreline, like a joke told by physics. You keep going, and the soil turns paler. Vegetation thins. The wind feels cooler than it should for this latitude, as if someone turned down the sun. And the closer you get to the Pacific, the more the dryness becomes not just a lack of rain, but a whole system built to prevent it. The ocean here is not warm and generous. Along much of this coast, a cold current slides northward. The Humboldt Current, fed by Antarctic waters and assisted by winds that push surface water away from shore. When surface water is pushed offshore, deeper water rises to replace it. This upwelling is cold and rich in nutrients and wonderful for marine life. It is also terrible at making rain. Cold water chills the air above it. Cool air holds less moisture, and it does not rise as easily. Instead of building tall storm clouds, the atmosphere tends to form a low marine layer. Fog and stratus, a flat gray ceiling that drifts inland and then gives up. So you stand near an ocean that is biologically busy, but meteorologically stingy. Fish thrive, seabirds gather, and the land stays dry enough to mummify mistakes. You think deserts are always hot? Wrong again. Some deserts are dry first and only incidentally warm. The Atacama, in its driest core, is not just a place with little rain. It is a place that can go years, even decades with almost none. There are weather stations that have recorded stretches without measurable rainfall that sound like errors. Here, the air can be so dry that even microbes struggle, not because it is toxic, but because water is a requirement and the planet is simply not providing it. There is a reason this desert can feel like another world, not because it is exotic, but because it is simple. Sun, rock, salt, wind, and long pauses. The ground crunches in places, crusted with minerals, nitrates, sulfates, salts, the leftovers of evaporation and chemistry, accumulated because there is no regular flushing rain to carry them away. These nitrates once drew people here for fertilizer and gunpowder, a reminder that even a desert can be mined for the ingredients of crowded human history. And humans Humans arrived, as they do, with straight lines and optimism. They built towns where the mining was. They hauled water from far away. They worked in air so dry your nose complains immediately, and in sunlight that feels sharpened. Some settlements faded when the money moved on. Others persisted, tethered to new industries, copper, lithium, astronomy, because this air, dry and stable, makes the night sky unusually clear. Yes, even here, humans find a way to turn emptiness into a job. On certain hills, you can see observatories, white domes against brown rock. Staring upward, a desert that cannot offer much water can offer something else. A sky with fewer clouds, fewer molecules, less interference. So while the coast stays foggy, the interior heights can be brutally clear. Two different atmospheres, stacked near each other, separated by topography. And that fog, it becomes the desert's strange compromise. In some coastal zones, fog drifts inland and clings to slopes. Locals have names for it, because of course they do. It is not rain, but it is moisture. Plants that live here learn to drink the air. They collect droplets on leaves and spines. They funnel water down stems. Some ecosystems exist largely on fog, thin green streaks on otherwise bare hills. Life adapts by becoming a patient accountant, saving moisture, spending it carefully, waiting for a storm that might not come for a long time. If you walk across a gravel plain here, you may see almost nothing living at first. Then you notice tiny shadows, a lizard that knows to move early and late, an insect that stays under stones, a hardy plant that looks dead until it isn't. And when a rare rain does arrive, the desert responds with a kind of quiet hysteria. Seeds that have waited for years can germinate quickly. Flowers can appear in patches, brief and bright. A bloom that looks like a miracle until you remember it is just stored potential meeting water. Then it fades again, because the system is not changing. It is only allowing a short exception. The mountains play their part too. They are not just a wall that blocks moisture from the east. They also shape wind patterns and stabilize the dryness on the west. Moist air from the Amazon side rises over the eastern Andes, cools, and drops rain there. By the time air masses cross the crest and descend toward the Pacific, they warm up and dry out further. Descending air suppresses cloud formation like a hand pressing down. So, you have a cold ocean discouraging convection and a high mountain range creating a rain shadow. Two systems agreeing in their own indifferent way to keep this coast dry. And yet, the dryness is not always stable. Every few years, the Pacific does something dramatic. Water warms in the equatorial ocean, winds shift, and the whole pattern wobbles. El Niño can bring rains to places that are usually dry. Not gentle rains either. Sometimes sudden downpours that hit bare ground that cannot absorb water fast enough. Then you get floods in a desert, which is always a strange sentence to say out loud. Dry channels, called quebradas in some places, can turn into violent streams. Mud and rocks move fast. Roads disappear. Hillsides slump. The desert does not handle surprise moisture gracefully. It has not practiced, so you learn the theme again. Even the quiet landscapes are built on conditions. Change the conditions, and the calm becomes chaos. But most nights, the coast remains what it is. Cool air, low fog, a desert that sits beside the sea and refuses to drink. If you stand on a bluff and listen, you might hear waves below, and above that, the wind, and beyond that, nothing. The land feels stripped down to essentials: rock, salt, and the long consequence of mountains. And if you turn your attention back upward, toward the highest peaks, you remember that moisture did not vanish from the Andes entirely. It only changed form. Because up where the air is thin enough and cold enough, water becomes something that can last, something that can pile up quietly, season after season, until it starts to move. Ice does not need permission. It only needs time. So you begin to climb again, in your mind, leaving the coastal dryness behind. The temperature drops as you gain height. Fog becomes cloud. Cloud becomes snow. And the ground turns from dust to stone. The highest Andes keep their water in storage. White patches that do not melt away in summer, because summer is not always strong enough up here. Snow that survives becomes compacted. Grains deform and fuse. Air pockets shrink. The snow becomes fern, and then dense glacial ice. A glacier is not a frozen lake. It is a slow river made of solid water. It flows under its own weight, creeping downslope with a motion too slow to see in a moment, but obvious across a lifetime. If you stand near the front of one, the air feels different. It is colder, heavier, like stepping into shade that has substance. The surface is pale blue where the ice is dense, and white where it is fractured and bubbly. You hear sounds that do not match the stillness: a crack, a distant groan, a drip that echoes. Congratulations, you are standing beside a machine that turns mountains into flour. Glacial ice plucks at rock as it moves. It freezes onto fragments, then tears them away. It grinds debris against bedrock, polishing and scratching the surface beneath. Those scratches, striations, are like a signature, a record of direction, a reminder that the ice was not resting even when it looked asleep. As the glacier advances and retreats, it reshapes valleys. It can widen them, deepen them, leave behind moraines, piles of debris dumped at the edges or the end of the ice. A moraine looks like a random ridge of rubble until you know what you are seeing. Then it becomes a timestamp, the place where the ice once reached when the climate was colder or wetter or both. And here is the part people forget when they romanticize mountains. Glaciers are water banks. They store water when it is cold and release it when it warms. They feed rivers gradually through dry seasons. They make life downstream possible. When the sun rises and the day warms the ice, meltwater appears. It runs in tiny channels on the glacier surface, clear and fast. It finds crevasses, disappears into blue cracks, and travels through hidden tunnels inside the ice. Then it emerges at the glacier's snout, milky with rock flour, and becomes the beginning of a river that did not exist a few hours earlier. In the Andes, those meltwater rivers can be everything. They irrigate valleys, they fill reservoirs, they spin turbines, they support cities that sit in dry country and pretend that water is normal. But the glaciers are sensitive. They respond to temperature and snowfall. If the balance shifts, the ice shrinks, and shrinking glaciers do something cruel. At first, they can increase meltwater because more ice surface is exposed. It feels like extra supply. Then, Later, as the glacier gets smaller, the supply drops. It is like spending savings faster than you replace them. For a while, you feel rich. Then, one day, you are just out. Some Andean glaciers have retreated dramatically in the last century. The exact pace varies by region, by elevation, by local weather patterns, but the trend is visible in photographs, in measurements, and in the exposed rock where ice used to be. You can walk to a viewpoint where a glacier once filled a valley, and now the valley holds a smaller tongue of ice, farther back, higher up, clinging to shade. Below it, a new lake may form, glacial meltwater ponds behind a moraine or bedrock lip, a cold blue mirror. These lakes are beautiful and sometimes dangerous. A moraine dam is not a concrete wall. It is a pile of debris, loose rock and sediment, held in place by friction and habit. If it fails, the lake can drain suddenly. A glacial lake outburst flood is exactly what it sounds like. Water released fast, rushing down a valley, picking up debris, turning into a moving slurry. Downstream, people may have no warning beyond a distant roar, a sound that arrives too late. So even ice, which looks like calm, contains motion and threat, not dramatic every day, but present, waiting in the structure of the landscape. And those meltwater rivers, once they leave the high zone, begin to do what rivers always do. They carry the Andes outward. They transport suspended silt that turns water opaque. They roll cobbles along their beds. They deposit gravel bars and build floodplains in flatter reaches. In some valleys, human agriculture depends on this system. Fields spread where the river has laid down fertile sediment. Canals divert water. Terraces step down slopes like careful geometry. But the river does not care about geometry. It migrates. It undercuts banks. It avulses, abandoning one channel for another during floods. Humans respond by building levees and walls, trying to hold a liquid line in place. Sometimes it works for a while. Sometimes the next high flow rearranges everything anyway. The Andes do not just supply rock and water. They supply risk, distributed slowly, then delivered suddenly. And yet people stay, because valleys are routes, because water is life, because highlands can be defended, because culture grows where it starts, and then it holds on. You drift farther downstream now, following the meltwater-turned river, leaving the immediate cold of the glacier behind. The air grows warmer, then warmer again. The slopes soften, the valley widens, and with each step away from the ice, the human layer becomes more visible. Stone walls, small towns, road cuts into steep hillsides, bridges spanning channels that look harmless in the dry season. You can tell where rivers have been angry before if you know what to look for. Boulders stranded on flats, scoured bedrock, trees bent downstream, a fresh fan of debris at a canyon mouth, like the land dumped its pockets all at once. This is the texture of living near young mountains. Young not in human terms, but in geologic terms. Still rising, still cracking, still producing relief that erosion and gravity can exploit. And the people who live here learn a kind of practical awareness. They know which slopes slump after rain. They know which rivers rise quickly. They know which volcano has been quiet for too long, even if nobody says it out loud. Some cities sit high, where nights are cold, even in the tropics. Others cling to coastal plains that can shake when the subduction zone adjusts itself. On the coast, ports face the Pacific, and the possibility of tsunamis is not theoretical. It is a known feature of the arrangement. In the highlands, buildings are often made of what is available: stone, adobe, brick, materials that hold heat and also hold a certain vulnerability when the ground moves sideways. Earthquakes do not ask what your walls are made of, but they do reveal it. Still, human infrastructure threads through the Andes because it has to. Roads snake up passes, hairpin after hairpin. Tunnels cut through ridges. Rail lines, where they exist, follow valleys like cautious animals. Every route is a negotiation with slope, altitude, and rock stability. And above all of it, the mountains continue their slow work. Subduction continues offshore. Magma forms and stalls. Faults accumulate strain. Ridges uplift by increments too small to notice, until you come back centuries later and realize the river has cut deeper. You move through this landscape like a temporary thought, a traveler on a moving planet, drawn to the places where the earth shows its seams. And as you keep drifting with the rivers into the human world, fields, towns, roads, and lights, you can still feel the older forces under everything, steady, quiet, and completely uninterested in schedules. So you build your little certainty anyway: a straight road, a square foundation, a calendar full of plans, on a crust that is actively being folded like laundry you forgot in the washing machine. Down here in the valleys, you feel how the Andes decide where easy will be allowed to exist. Flat ground is rare, and when you find it, it is usually borrowed from a river, a floodplain, a terrace, an alluvial fan, land made from yesterday's erosion. You can stand in a town that looks permanent: painted walls, corrugated roofs, a market, a school, a church that has outlived several governments. But the whole settlement is perched on a geologic compromise. The river beside it is not just water. It is the Andes, dissolved into motion. It is pulverized volcanic rock, ground into silt by glaciers, carried downhill, and delivered like an invoice. And because humans are predictable, you follow the water. You follow it to where it is slowed, captured, measured, and negotiated over. A diversion gate, a canal, a reservoir, a system designed to take a wild thing and make it punctual. Irrigation in these landscapes is not a luxury. It is a method for stealing a little certainty from a climate that does not offer much. Fields appear in long green ribbons where gravity and engineering agree. Potatoes, quinoa, maize, grapes, alfalfa, each crop an argument with altitude and dryness. Terraces are the most honest architecture here. Steps cut into steep hillsides, held by stone walls, each one a small refusal to let soil fall away. You do not build terraces because you enjoy extra work. You build them because flat ground is not available for purchase. And the Andes reward effort with mixed results. A good season and the valley looks soft and generous. A bad season and the river drops the soil dusts over, and everyone watches the sky like it owes them money. Sometimes the problem is not drought. Sometimes it is too much water arriving too fast. A storm higher up, a sudden melt, an unusual warm spell, and a quiet channel becomes a conveyor belt of mud. The valley floor remembers, even when people pretend they do not. You can tell where old floods ran if you look for clumsy boulders, stones too large to be carried by normal flow, parked like abandoned cars. They are evidence of a day when the river stopped being polite. And the truth is, even when the weather behaves, the ground still has its own schedule. Because in an active mountain belt, gravity is always negotiating with friction. A steep slope is not stable. It is only waiting. You might drive along a mountain road and see scars in the hillsides, fresh pale rock where a landslide peeled away vegetation, a slope netted with wire, like the mountain has been wrapped to keep it from shedding. Concrete barriers, warning signs, and a thin line of asphalt pretending to be confident. Congratulations, you have built infrastructure in a place that is actively trying to return to the valley floor. The Andes are famous for earthquakes, and not just the deep offshore ones. There are faults in the mountains too, faults that slice through crust thickened by compression. Some earthquakes are shallow and sharp, the kind that throw objects off shelves and turn masonry into dust. Others are deeper, rolling through the ground like a slow truck passing beneath your feet. In the cities, people learn the difference between swaying and jolting. They learn which buildings creak and which ones crack. Modern codes help when they are followed. Older structures, especially unreinforced brick and adobe, do not love sideways motion. And yet, after the shaking, there is always this strange human pause. A moment where everyone stands still, listening for the aftershock, checking the walls, checking each other. Then, because life insists, someone boils water, someone sweeps debris, someone opens a shop. The planet moves on, and so do you. There is another kind of hazard here that does not need shaking. It needs only gravity, water, and loose volcanic material. A lahar does not care if the volcano is erupting today. It cares if there is ash on the slopes and rain in the clouds. In some valleys, people build lahar channels and barriers. They map the routes the mud will take because the mud has been here before. You can feel the practical humility in those maps. Not fear, exactly, more like a quiet acknowledgement of who has the final vote. And then there are the volcanoes themselves. Most nights, they do nothing at all. They sit under stars, wearing snow like a calm disguise. But the Andes have a long memory of eruptions, explosive ones, the kind that produce towering ash columns. Andesitic and dacitic magmas are common here, thicker magmas that trap gas more easily. Gas pressure builds, and when it releases, it can do it violently. Ash can fall far from the crater, turning daylight into a dimmer version of itself. It can clog engines, scrape lungs, collapse roofs if it accumulates wet and heavy. Air travel stops, roads become gritty, water supplies turn questionable. A volcano does not need lava to ruin your week. Closer to the vent, the hazards get more intimate. Pyroclastic flows, fast, hot avalanches of ash and gas and rock fragments. They move like a liquid cloud, hugging the ground, following valleys the way water would if water was furious and boiling. These are the moments that remind you the mountain is not scenery. It is a vent in a crust that is being cooked from below. And still, people live near these peaks. Because volcanic soils can be rich once they weather, because valleys are pathways and water is there, because the view is honestly, unfairly beautiful. In the Andean world, beauty and danger share the same address. You drift into a city now, one of those high cities where the night air cools quickly, street lights glow, and the mountains become dark shapes beyond the last buildings. If you listen closely, you can hear the city's sound change with altitude. Engines strain a little more, voices carry differently in thinner air, and the cold makes everything sharper. High altitude also changes the math of daily life. Water boils at a lower temperature, so cooking takes longer, and tea feels like it is not trying. Fuel burns differently, and lungs work harder, especially if you arrived too quickly. People born here move with an efficiency you do not have yet. And because humans cannot resist building a story on top of a landscape, you start seeing the cultural ways people have adapted. Clothing designed for cold nights and bright sun. Markets timed around weather windows. Festivals tied to planting, to harvest, to the return of rains that are never guaranteed. Even religion and ritual get shaped by geography. Because geography is not a backdrop, it is a constant pressure on the body and the calendar. You can call it tradition, but often it is just survival with better poetry. In some valleys, you see ancient stonework, fitted so tightly it looks modern, a reminder that people have been negotiating with these slopes for a very long time. The Inca and their predecessors understood something basic and unromantic. If you want to live in mountains, you build with the mountains, not against them. So, you find roads that follow ridgelines and valleys, not because it is scenic, but because it is possible. You find storage systems for food because a snowstorm can close a pass. You find redundancy because a single path can disappear under a landslide. And the modern world adds its own layers. Hydroelectric dams in deep valleys, capturing meltwater and turning it into light. Mines clawing into high ridges, following copper and silver and tin, following the chemical generosity of subduction. Pipelines, power lines, and switchbacks, a web laid over rock that does not promise to stay still. Mining in the Andes is its own kind of geography lesson. Ore deposits here are not random. They are tied to the arc of magma, the chemistry of melting, and the hydrothermal fluids that move through fractures. Hot, mineral-rich fluids rise, cool, and deposit metals in veins and porphyry systems. Porphyry copper deposits. That phrase sounds sleepy enough, and it should. It is just a giant, low-grade metal deposit spread through a lot of rock, but it becomes a mountain of money if you are willing to crush, grind, and process enormous volumes. The mines sit high because that is where the geology put them. And working high is exhausting even when you are not doing the digging yourself. Machines lose power, humans tire faster, and every small task demands more oxygen than you want to spend. Water becomes a bitter topic. Mines need water, towns need water, farms need water, ecosystems need water, and in dry regions, especially on the western slopes and plateaus, the supply is seasonal and limited. A glacier retreat upstream is not an abstract climate chart. It is a future argument. So you see pipelines bringing water from elsewhere, reservoirs hoarding it, and legal battles over who gets to drink. The Andes make a lot of conflicts feel inevitable because they concentrate resources into narrow corridors. And yet, there is also a deep calm in the way people keep living. A routine formed in the shadow of uncertainty. You learn which months are safer, which slopes to avoid, which rivers to respect. You learn that normal is just a period between reminders. Sometimes the reminders are subtle. A fresh crack in a wall after a distant quake. A new spring where water found a fracture. A hillside that slumps a few centimeters after heavy rain. Bending fence posts like tired fingers. Sometimes the reminders are loud. A coastal earthquake that knocks power out for a city. A tsunami warning that empties beaches in minutes. An eruption that dusts a region in ash, turning everything matte and gray. The coastal cities live with the ocean's hidden boundary. The highland towns live with gravity and cold. The plateau communities live with thin air and water that arrives like a rumor. Different chapters, same book. And if you pull back in your mind, above the towns and fields and roads, you start to see the Andes again as a single long system. A spine running down a continent, created by subduction, maintained by compression, and constantly modified by erosion. This is the part that feels almost comforting in a bleak way. The predictability of the process, even if the outcomes are chaotic. The oceanic plate continues to slide beneath South America, not every second, not every day, but always at the scale the planet prefers. The slab sinks, heats, releases water, melt forms above it, volcanoes build and rebuild. The crust shortens, thickens, and rises. Even when the surface looks quiet, the deep story keeps going. You might imagine the Andes as finished because they look complete. They have peaks, they have snow, they have maps and names, but mountains are not monuments. They are negotiations. If the subduction stopped tomorrow, the Andes would not collapse like a bad stage set. They would simply begin to lose, slowly, to erosion. Rivers would keep cutting. Glaciers would keep grinding where cold allows, and slopes would keep failing. Over millions of years, the relief would soften, but subduction has not stopped. So the Andes exist in this strange balance, a push upward matched by a pull downward. A long tug of war with no audience, no prize, and no referee. In some parts of the range, uplift has been rapid in the geologic sense. In other parts, it is slower. The angle of the subducting slab changes, and with it, the position of volcanism and deformation. There are segments where the slab is flatter and volcanism can diminish. There are segments where it dives more steeply and the arc becomes more active. These variations matter because they shape where basins form, where ridges rise, and where earthquakes cluster. The Andes are one range, but they are not one simple mechanism. They are a stitched seam with different tensions along its length. And then there is the subtle, heavy idea that the mountains influence the very climate that erodes them. Raise a barrier, and you reroute winds. Create rain on one side, dryness on the other. Grow glaciers on high peaks, and you add a new erosion tool. Starve a slope of vegetation, and you make it more vulnerable to sudden flows. It is a feedback loop. The mountains build the climate, and the climate carves the mountains. Even the Amazon basin, far to the east, is connected to this. Moisture from the Atlantic moves inland, feeds the rainforest, and some of that moisture eventually meets the Andes. The mountains force air upward, wringing out rain that feeds Andean rivers. Those rivers carry sediment back toward the lowlands. The Andes help generate the sediment that helps build the plains. The plains feed the rivers that help shape the foothills. Everything is linked by gravity and water. And if you listen for long enough, you can hear that link in a single drop of rain. It hits a ridge, runs into a thread of water, joins a stream. The stream joins a river, the river carries silt, the silt settles in a basin. Later, it becomes rock, and later still, it might be lifted again. A cycle that turns landscapes into temporary arrangements. You are not just visiting a mountain range. You are watching a process that has not decided to stop. And because the earth enjoys repetition with small variations, your mind drifts back offshore again, to where the story began. Not to repeat it, but to feel its steadiness. The trench out in the Pacific is still there, hidden under black water and swells. The plates are still converging. The boundary is still locked in places and creeping in others. Somewhere beneath the sea, stress is building for an earthquake that does not know your calendar. If you could see through water and rock, you would watch the oceanic slab descend like a slow escalator into heat. You would watch minerals break down and release their stored water. You would watch that water trigger melting in the mantle wedge above. And you would watch magma rise, stall, cool, and sometimes gather enough persistence to reach the surface. The Andes are the surface expression of that deep, unshowy machinery. When you stand on a high pass at night, the cold makes the air feel clean and severe. Stars look closer, and the ridges form black silhouettes that seem too sharp to be real. It can feel like the mountains are eternal. But look closer, in your mind, and you see the signs of impermanence everywhere. A talus slope under a cliff, piles of broken rock that were once part of the wall, a river cutting a canyon deeper each year, even if you cannot measure it with your eyes, a glacier with a fresh band of bare rock beside it, marking where ice used to be. Even the peaks are in motion, not walking, not shaking, just changing quietly under the influence of temperature and gravity. Freeze-thaw cycles pry at fractures. Water seeps into cracks, freezes, expands, and wedges rock apart. This is frost weathering, simple and relentless. It turns solid ridges into loose debris, one winter at a time. Chemical weathering works too, even in cold places. Just slower. Minerals react with water and air, forming clays and oxides. Iron stains rock reddish, sulfur can add harsh colors near volcanic zones. The mountains begin to rot in a very slow, very patient way, and then gravity collects the results. Debris slides, tumbles, creeps. A slope does not need an earthquake to move. It only needs steepness and time. In the Andes, steepness is abundant, so the mountain range breathes. Uplift in slow pulses, erosion in constant whispering, occasional sudden failures. A system that never rests, only pauses. If you stay with that thought, you begin to see why the Andes have such a long influence on human patterns. Routes follow the few places where the range is willing to be crossed. Passes become strategic, culturally and economically. Valleys become corridors. Coasts become nodes. In the north, where the Andes meet wetter air and tropical climates, you get cloud forests, steep slopes draped in moss and orchids dripping with water. In the central Andes, you get the high plateau, thin air, salt flats, and fierce sun. In the south, you get Patagonia, winds that never seem to get tired, and glaciers that reach down toward green valleys. One range, many moods, all of them tied to subduction, latitude, and elevation. And speaking of elevation, there is a quiet, physiological truth that follows you through this entire landscape. At higher altitudes, the partial pressure of oxygen drops. Your body notices whether you want it to or not. If you arrive quickly, you might get a headache, nausea, sleep that feels shallow, not because the mountains are evil, but because your blood chemistry is catching up. Given time, many people acclimatize. Your body produces more red blood cells, adjusts, breathing, adapts. Some populations have lived at altitude for thousands of years and show genetic adaptations that help. Different Andean groups have different physiological strategies. It is evolution doing its slow work in thin air, the same way tectonics does. So in a strange way, the subduction zone shapes not only rocks, but bodies. It creates high places, and high places select for certain tolerances. Geography becomes biology, quietly, over generations. And still, for all these adaptations, the mountains keep setting limits. Agriculture has altitude bands where certain crops succeed and others fail. Pasture exists where grasses can survive cold and dryness. Above a certain line, trees disappear. The tree line is a climate boundary written in wood. Above that, you get puna grasslands and hardy shrubs. Above that, bare rock and snowfields. And above that, just air, thin enough to make you feel like you are borrowing it. This vertical zoning is one of the Andes' most practical lessons. You do not need to travel far to change worlds. You only need to go up. A few thousand feet of elevation can turn a warm valley into a cold plateau. It can shift rain patterns, plant communities, and the entire rhythm of life. That is why Andean landscapes can feel so varied so quickly. They are stacked like layers of climate on a single slope. And when you look at the range that way, as a stack of environments, you understand why it has always been a place of movement, not just across the mountains, but up and down them, seasonally. Herding routes, trade routes, migration patterns shaped by snow, pasture, harvest times. Even today, modern roads follow old logic. They climb when they must. They drop when they can. They cling to ridges to avoid unstable valley walls. A mountain does not care about your desire for a straight line. In the nighttime, when traffic quiets and the wind moves through gullies, the Andes feel almost empty again. Cities dim, and the range returns to its older identity. Rock, cold, and a deep internal pressure. You could fall asleep here easily if you did not know what was beneath you, or perhaps because you know. Because there is something oddly calming about a process that does not require your participation. The subduction zone will keep going whether you worry or not. The mountains will keep rising and eroding, regardless of your plans. The rivers will keep carrying away grains of the range, one small theft at a time. And as you keep moving along this idea, deeper into the ongoing process, you begin to sense the Andes, not as an object, but as a verb, a continent being shortened, a slab descending, a mantle melting, a crust thickening, a skyline adjusting, a long, unfinished mountain range still under construction, still under demolition, still balancing the books. And somewhere along the western edge, the ocean continues to press in, quietly, as if it has all the time in the world, because it does. That slow pushing does not just build mountains, it builds a kind of quiet suspense, because when rock is forced downward, something else tends to rise. You can picture it below your feet, even if you never see it. The descending slab, carrying cold, wet minerals into heat, the mantle above it softening just enough to make a melt, and that melt trying to find daylight. Not all of it succeeds. A lot of magma in the Andes dies underground, cooling in place, becoming intrusive rock, granite bodies and dikes and sills that will only be exposed after erosion peels the range back like old paint. So, in a way, you are looking at a mountain range with a hidden basement, an entire architecture of frozen magma beneath the surface, proof that the planet tried many times and only sometimes bothered to erupt. When magma does reach the surface, it rarely does it politely here. These are not the easy, watery lavas you might imagine from a Hawaiian postcard. A lot of Andean magma is stickier, higher in silica, reluctant to flow. It traps gas, it builds pressure, and it turns volcanoes into complicated machines. You see the result in the shapes. Stratovolcanoes, layered cones built from alternating lava flows and explosive ash deposits, lava domes, thick piles of magma that ooze out and stack up near the vent like toothpaste with bad intentions. Calderas, wide collapse craters formed when a magma chamber empties fast enough that the roof gives up. A caldera looks peaceful from a distance. It is a broad bowl, sometimes filled with a lake, sometimes dry and quiet, but it exists because the ground fell in. Not metaphorically, literally. Congratulations, you are admiring a landscape feature made by structural failure. And even when nothing is erupting, the Andes still breathe chemicals. In volcanic zones, you can find fumaroles, vents that exhale steam and sulfur gases. The air around them smells like struck matches and damp stone. Hot springs appear where groundwater meets heat, rising back up with dissolved minerals, staining the ground orange, white, or green. Those stains are not decoration. They are chemistry. Iron oxidizing, sulfur crystallizing, salts precipitating as water cools, the mountain range quietly labeling itself. If you linger in one of these high volcanic basins, you notice something else. The ground can be warm in patches. Snow melts in odd spots. A thin crust forms on pools, then breaks with a brittle snap. It is easy to forget up here in the thin air that you are standing above a heat engine. A slow one, yes, but a stubborn one. And the heat has consequences beyond eruptions. It builds ore. Hot fluids move through cracks in the crust, carrying metals in solution. As those fluids cool or react with surrounding rock, they drop their load. Copper, molybdenum, silver, gold, tin, concentrated not by luck, but by plumbing. The Andes, in that sense, are not just mountains. They are a long industrial invitation. Humans see a ridge and think, maybe there is something valuable inside. The planet answers, sometimes with a very expensive yes. So you get mines high on ridge lines, where the air makes every step feel like a negotiation. You get roads carved into slopes, switchbacks stacked like tired handwriting. You get tailings piles, pale and dusty, perched above valleys that did not ask for them. And then, because the Earth is never satisfied with a single hazard at a time, you get earthquakes that can shake those same slopes. You do not need an apocalypse for trouble. You only need vibration. A shaking slope can liquefy its loose sediments, especially if they are saturated. That word, liquefaction, sounds almost elegant. In human terms, it means the ground stops acting like ground. Sand and silt lose strength, and buildings tilt, and roads buckle. It is one of those reminders that solidity is conditional. But the strange thing is, in between these reminders, most days feel normal. That is how you can live in a subduction zone. Normal is a long, quiet stretch, interrupted by brief demonstrations. You begin to sense that the Andes shape human time, not just in calendars, but in how far ahead you plan, in how you build, in what you keep stored, in whether your house is stone or reinforced concrete, or something light enough to fall without killing you. And because the Andes run for such a long distance, the relationship changes from place to place. In some regions, cities sit in basins surrounded by faults. The ground there can amplify shaking because soft sediments wobble like gelatin. In other regions, towns cling to hard rock, and shaking feels sharper but shorter. Same earthquake, different experience depending on what you built your life on. Even the coast has its own version of this. Some stretches lift during earthquakes, others sink. A harbor can become too shallow or suddenly deeper. A shoreline can shift enough to leave old piers stranded above the waterline, like forgotten ribs. And then there is the ocean response, the long wave you cannot see until it is close. A tsunami is not a breaking wave out at sea. Out there it is a moving swell, a subtle rise and fall stretched over long minutes. Ships barely notice. The deep ocean carries it quietly. It becomes dangerous when it reaches shallow water. The wave slows, stacks up, and grows taller. And when it reaches land, it does not arrive as a single dramatic crest. Often it arrives as a surge, a fast-rising flood that keeps coming. It is not water leaping. It is water relocating. Coastal communities learn the vocabulary of evacuation. They learn that if the ground shakes hard near the shore, the ocean is not your friend for a while. They learn to run uphill, not because uphill is scenic, but because gravity is predictable. And then, after, they rebuild because coasts are useful, because ports matter, because humans have short memories and long mortgages. Up in the mountains, the hazards are different, but the theme is the same. People settle where the land allows it, and the land allows it only temporarily. You notice it in the way Andean valleys are used. The flat valley floor is precious, so it gets farms, houses, roads, everything. The steep slopes are left to grazing, or forest where it exists, or nothing at all. And yet, the valley floor is the part the river will take back during a flood. So you live in a place where the best land is also the most borrowed land. In the high plateaus, life leans on water that arrives in pulses, seasonal rains, glacial melt, groundwater in salty basins. You build canals, you dig wells, you argue about rights, you measure snowpack like it is a bank balance. And sometimes the water has opinions. In El Niño years, the Pacific warms, the atmospheric patterns shift, and the usual dryness can break. Rains fall where they do not belong. Desert hillsides shed mud. Rivers rise fast, carrying debris that clogs bridges and fills channels. You learn that rare events are the ones that define the landscape. Most years do not matter much. One year rearranges everything. Speaking of rearranging, you start noticing something subtle about these mountains. They are not symmetrical. The western side, facing the Pacific, often drops more steeply in places. With narrow coastal plains, the eastern side can have broader foothills and long river systems draining toward the Amazon basin. That asymmetry is not aesthetic. It is geometry, climate, and tectonics working together. On the west, the subduction zone is close. The crust is compressed and uplifted near the edge. Rivers have shorter distances to reach the sea, so they can cut steep canyons. In arid regions, those canyons stay sharp because vegetation does not soften them. On the east, moisture is more generous. Rivers are larger, more persistent, able to transport huge sediment loads. Over long time, they build wide floodplains and megafans, sprawling deposits that spread like slow spills across the lowlands. So, depending on which side you drift down, you end up in very different worlds. If you follow water eastward, you can imagine the Andes dissolving into the Amazon basin, grain by grain. The river turns from a mountain torrent into a wide brown conveyor, carrying silt that once belonged to peaks. That silt makes soil. That soil supports forest. That forest recycles moisture back into the air, feeding more rain, feeding more rivers. It is one of the planet's more elegant loops, mountains feeding a rainforest that helps keep mountains wet enough to erode. And if you follow water westward, you get a different ending. Short rivers, often seasonal, sometimes reduced to dry beds. Where water does reach the sea, it can do it suddenly, in bursts, after rare storms. The Andes, in that sense, do not just divide land. They divide how time feels. Wet side, where change is constant and green. Dry side, where change is rare and violent. And everything in between is still. But none of these worlds are stable in deep time. You can step back and look at the Andes as a work in progress. And then remember the deeper insult. Even this is temporary. Subduction zones migrate. Plate motions change. The angle of the slab shifts. Volcanic arcs can move inland or shut off in segments. Basins can rise. Rivers can reroute. Climates can swing with global changes. And the mountains respond the way mountains always do, by slowly becoming something else. You can see hints of that future in the present. In some places, the Andes have broad, high, relatively flat surfaces, remnants of older landscapes that were lifted upward. Old erosion surfaces, once near sea level, now stranded in the sky. They are like pages stuck together in a book, evidence that uplift came after a long period of wearing down. In other places, the range is deeply dissected, cut by rivers that have had time and water to do their work. Canyons that look too big for the streams inside them, because the streams were larger in the past, or because uplift gave them extra slope, extra energy. Sometimes you find hanging valleys where a smaller tributary valley meets a deeper main valley, leaving a sudden drop, often a waterfall, a signature of glacial carving where ice deepened one valley more than its neighbor. Sometimes you find river terraces, flat steps above the current river level. Each terrace is an old floodplain abandoned when the river cut down again. A record of changing sediment supply, changing water flow, or changing uplift rates. The landscape is full of these quiet receipts. You do not need to read them all at once. You only need to notice that the mountains are not a single shape. They are a collection of processes, layered. And as night settles over this whole spine of land, you can imagine the Andes continuing without you. Far offshore, the plates keep converging. Deep below, earthquakes start and stop, too small for anyone to feel, tiny adjustments in the contact zone. Higher up, the crust flexes and stores strain. In the volcanic arc, magma chambers cool, recharge, evolve. At the surface, frost cries at cracks. In valleys, rivers move sediment downstream. On high peaks, ice creeps a little farther or a little less, depending on the year. It is all motion, just spread out across different speeds. If you want a more human scale proof that the Andes are unfinished, you can look at a map of recent earthquakes. The dots trace the subduction zone like a seam. Shallow quakes near the trench, deeper ones inland, following the descending slab, a dipping plane of seismicity. It is called the Wadati-Benioff zone, which sounds like two professors you do not want to disappoint. In human terms, it is a trail of brittle failure marking where the slab is still cold enough to crack as it goes down. And it goes down far. Hundreds of miles beneath the continent, the slab continues, sinking into hotter mantle. Eventually, it heats enough that it stops breaking the same way. It becomes more ductile, more willing to flow than fracture. The earthquakes fade, not because the slab is gone, but because the rules changed. But before that, while it is still cracking, it reminds you that the Andes are rooted deep, not in symbolism, in geometry. Now, drift back up to the surface again, because the surface is where the irony lives. You can stand on a calm street in a mountain town, and everything looks permanent. A dog asleep in the doorway, a vendor closing a stall, a bus coughing its way uphill. And underneath, the crust is being shortened like fabric shoved into a drawer. You can stand in a vineyard on the western slopes, irrigated with meltwater, and look up at peaks with snow. Grapes in a desert-adjacent valley, growing because the planet stores water as ice up high. It is a strange dependency. When you say it plainly, you can stand in a high plateau mining district where the wind never seems to stop and watch a line of trucks carrying ore. Metal born from subduction, extracted with diesel and patience, hauled across uplifted crust to be turned into wiring and devices far away. And all of it sits on a boundary that can, on the wrong day, shift a few feet in seconds. So yes, people adapt, but mostly people normalize. They normalize risk the way you normalize background noise, until the noise gets louder and you remember it was there. If you keep following this thread, you start thinking about how the Andes look from very far away. From orbit, they are a pale spine along the western edge of South America. They catch clouds on one side, cast dryness on the other. They steer rivers, define borders, shape trade routes, and create ecosystems stacked by altitude. They are so long that they connect climates that have nothing else in common. Equatorial volcanoes with glaciers on their tops, because altitude can beat latitude. Mid-latitude deserts, where the ocean is cold and the air refuses to rain. Southern fjords and ice fields where the wind has learned to be cruel. One mountain system stitched to the same tectonic arrangement. And as you sit with that, you start to feel the deeper pattern, not just for the Andes, but for the planet. Subduction is how Earth recycles. It drags old seafloor back into the mantle. It returns water and carbon and sediments to depth. It drives volcanism that releases gases back to the atmosphere. It builds continents, reshapes coastlines, and makes the surface restless. A planet without subduction would be quieter. It would also be more static, more sealed off, less able to refresh its skin. Here, the Andes are the visible price of that recycling. A long, high scar of a system that never learned to stop. And if you let your mind wander along the range again, you can find places where the story gets very specific. In southern Chile and Argentina, the subduction zone feeds volcanoes that sit near wet forests and glacial valleys. Here, eruptions can melt snow and ice quickly, sending floods downstream. Ash falls on pastures, on towns, on lakes, turning water strange and opaque. In Peru, you find deep canyons cut into uplifted terrain where rivers have had time and slope to excavate. The canyon walls show layers, folded and faulted like a geology textbook left open. In Bolivia and northern Chile, you find the Altiplano, that high plateau you already crossed in your mind, where salt flats sprawl under a hard sky. Here, volcanism leaves behind not just cones, but entire fields of ignimbrite, deposits from enormous explosive eruptions long ago. Ignimbrite is welded tough, ash that was so hot when it landed that it fused into rock. That is a calm sentence for a violent event. It means an eruption produced a pyroclastic flow so massive it blanketed the land, then cooled into a sheet. Later, erosion cut into it, revealing cliffs of pale volcanic rock, sometimes with columns and joints like a cracked cake. And in Ecuador and Colombia, you find volcanoes close to populated valleys where fertile soils and water draw people in. The same slopes that grow crops can also channel lahars. So communities build with one eye on the mountain, even when they pretend they are not. Everywhere, the pattern repeats with local variations. Now, the outline of your journey is still carrying you forward. Because after people, after cities and mines and terraces, the story wants to return to the big, unfinished truth. The Andes are not done. And you can feel that most clearly in the way the mountains refuse to settle into a single shape. Think about a mountain range you have seen that feels old. Rounded ridges, wide valleys, soft slopes. The Appalachians, for example, worn down over hundreds of millions of years. They are ancient bones, sanded smooth. The Andes are not that. The Andes are sharper in many places, more abrupt, less eroded into humility. Not everywhere, not uniformly, but enough that you can sense youth in their steepness. Youth in geology is still millions of years, which is an annoying perspective to keep. But the relative youth shows in the active faults, the frequent earthquakes, the high relief. The Andes are still being pushed, still being thickened, still being fed heat, and the erosion is still trying to catch up. If you want to imagine that balance, you can picture a scale. On one side, uplift, crust being shortened and thickened by compression, volcanic additions ash and lava building cones and plateaus, isostatic responses, the crust floating higher as it thickens. On the other side, erosion, rivers cutting downward, glaciers grinding, wind removing fines, landslides dropping material into valleys, sediment being carried to basins, to plains, to the sea. The scale never settles. It trembles. In wetter climates, erosion can be aggressive because water is available to move material. In drier climates, erosion is slower most days, but can be extreme during rare storms. In cold, high places, ice takes over the heavy work, moving rock whether the liquid water is present or not. So the Andes rise unevenly, and they wear down unevenly, and the result is a patchwork of landscapes. And beneath all that, the deep driver keeps driving. The Nazca Plate, the oceanic plate offshore, continues its slow approach. It is not a smooth slab either. It carries ridges and seamounts, roughness on the seafloor that can affect how subduction behaves. When a buoyant ridge enters the trench, it can change the angle of the slab, change the coupling, change the pattern of uplift. So even the seafloor topography matters, even though you never see it. The Andes are, in part, a response to what is being fed into the subduction machine. And the machine has moods. Sometimes the slab dips steeply and volcanism is strong, a clear arc of active peaks. Sometimes the slab flattens and volcanism can shut off in that segment, even while compression continues. Flat slab subduction is like a stubborn board sliding under a rug, forcing deformation farther inland. That is why some parts of the Andes have volcanic gaps, not because the system is broken, but because the geometry changed. And geometry is destiny. When you are made of rock. You can also notice how the mountains affect the crustal thickness. Under parts of the central Andes, the crust is exceptionally thick, tens of miles of buoyant continental material. That thickness helps support high elevations, like the Altiplano, by sheer floating physics. And thick crust has its own internal consequences. It can get hot inside, not just from magma, but from insulation. Thick crust holds heat, allowing metamorphism, partial melting, and the slow weakening of rock at depth. That can influence how the range deforms, how faults behave, how uplift is distributed. So the Andes are not just pushed from below by subduction, they are also internally adjusted by their own thickness, a mountain range that develops an interior life. And while you are thinking in deep time, you can let your mind drift to a quieter kind of measurement. Not seismographs, not satellite radar, not instruments. Just the shape of a river. Rivers respond to uplift. If the land rises, a river can steepen its gradient and cut down, creating nick points, sudden changes in slope. Those nick points can migrate upstream over time, like a slow-moving step in the river profile. Waterfalls and rapids can mark these transitions. In bedrock canyons, the river can incise, leaving terraces. So if you see a river slicing deep into uplifted terrain, it is telling you something. It is telling you the land is rising, or has risen, faster than the river could adjust smoothly. And if you see wide meanders entrenched in rock, curves cut deeply into canyon walls, that tells you something too. It suggests the river once meandered on a low gradient plain, then the land uplifted and the river cut down, preserving its curves as it incised. The river keeps its habits, even when the ground changes beneath it. Humans do that too. You can build a town where the valley is wide because it feels safe. You can build a road along a river because it feels sensible. Then, uplift, erosion, and occasional earthquakes remind you that sensible is not the same as permanent. Even the cultural patterns along the Andes reflect these corridors. Trade and language tend to follow valleys. Isolation happens across ridges. High passes become political in the way only geography can manage. A border drawn on a map is one thing. A border drawn by a 10,000-foot ridge is another. And then there is the coast again, always waiting, always pressed against the mountains, like a thin strip of habit. The coastal plain, where it exists, is often built from sediments washed down from the Andes. Alluvial fans spread out where rivers leave mountain fronts, dumping their load as slope decreases. Those fans can host cities because they are flatter. But fans can also be active. A fan is not a gift. It is a deposit. It means the river has changed channels many times, spreading debris across a broad area. Build on it, and you are building on the memory of flow. In dry climates, fans can look stable because nothing has happened recently. But the next rare storm can reactivate channels. Water chooses a path, and the path might be under your house. This is how the Andes keep teaching the same lesson in different dialects. Everything is process. Everything is temporary. Some things are just temporary on a schedule too slow for your nervous system to respect. Now, hold on to that, because the unfinished nature of the Andes is not only about danger, it is also about how mountains can be both created and erased at the same time. In deep time, the highest peaks are not necessarily the oldest. They can be the newest expression of uplift, and the places that look subdued can be old highlands that have been worn down, or they can be areas with less uplift, or different rock types, or different climates. Rock type matters more than people expect. A ridge made of hard igneous rock can resist erosion longer. A slope made of fractured sedimentary layers can crumble faster. A valley cut into volcanic ash deposits can widen quickly because the material is weak. A canyon cut into granite can stay narrow and steep because the walls hold. So as you drift along the Andes, you are also drifting across lithology, the geology word for what the rocks actually are. And those rocks are varied because the Andes are an accretionary collage. Bits of oceanic crust scraped off and plastered onto the continent, sediments folded and metamorphosed, volcanic arcs built on top of older arcs, basins filled, then uplifted, then eroded again. In some places, you can find ophiolites, pieces of ancient ocean floor exposed on land, like the planet forgot to put them back. In some places, you can find high-grade metamorphic rocks formed deep in the crust, now lifted and exposed. Each outcrop is a clue that the surface is not the original surface. It is a cross-section, revealed by erosion. You are walking through the inside of a system, and because you are still you, human and soft, you experience all of this as weather and effort. A high ridge is cold at night. A valley traps heat by day, then loses it quickly. Wind accelerates through passes because air is a fluid, and mountains are valves. Clouds form on windward slopes and break on leeward sides, like the atmosphere is being combed. You do not need to know every technical term to feel the physics. You can feel katabatic winds at night, cold air draining downslope like invisible water. You can feel the way sunlight is harsher at altitude because the air is thinner and filters less. You can feel dehydration arriving faster because the air is dry and your breath carries water away. The Andes ask more of your body, and that is part of their hold on the imagination. But again, this is not a travel story. This is a construction site the size of a continent, and it is still active. Somewhere beneath the range, faults are creeping slowly or locked and storing strain. Somewhere offshore, the plate interface is doing the same. Some volcano is degassing quietly, releasing sulfur dioxide in quantities small enough to ignore until you cannot. And somewhere, erosion is doing its work so patiently it feels like nothing. A cliff face expands and contracts with daily temperature changes. A tiny flake of rock detaches and falls. It hits a slope, bounces, settles among other fragments. In the next rain, it moves again. In the next flood, it goes farther. Eventually, it reaches a river big enough to carry it as sand. Eventually, it reaches the sea. Eventually, it settles on the seafloor as sediment. And if the plate motions keep their current arrangement, that sediment may be scraped, buried, lithified, and dragged down again. The Andes recycled. Now, keep moving forward in your mind, because you are approaching the part of the story that looks like a conclusion, but is not. It is only the wider view. The long, unfinished mountain is not a metaphor. It is a literal statement about forces still operating. The Nazca Plate is still being created at a mid-ocean ridge far out in the Pacific. New crust forms from upwelling magma, cools, and begins its long voyage east. Over millions of years, it becomes denser, colder, heavier. Then it arrives at the trench and begins to sink. So, the Andes are connected to a feature you might never think about while looking at them. A spreading ridge thousands of miles away, feeding the supply of oceanic crust that will one day disappear beneath South America. Creation out there, destruction here. Mountains as the side effect. And the rate is slow, but the total is enormous. Over tens of millions of years, that conveyor belt has moved whole oceans worth of crust. It has delivered water into the mantle, carbon into depth, sediments into heat. It has produced magma volumes large enough to build plateaus, arcs, and intrusive complexes. It has shortened the continent, thickened it, lifted it. It has made the Andes. And yet, even in that long span, the Andes have changed character. There were times when uplift intensified, when climate shifted, when erosion patterns changed. There were times when glaciers expanded in the tropics, carving valleys that now sit above warmer air. There were times when the Atacama became even drier, when upwelling and atmospheric circulation locked into a stronger pattern. There were times when river networks reorganized, capturing each other, cutting new routes. River capture is another quiet drama. A river on one side of a divide can erode headward, cutting back into the ridge, eventually stealing the flow from a neighboring basin. The stolen river suddenly has more water, more power, and it cuts deeper. The abandoned valley becomes underfit, with a small stream in a valley too big for it. So watersheds are not permanent either. Even the direction a river flows can be negotiated over millennia. The Andes are full of those slow negotiations. And if you keep that in mind, you stop thinking of the range as a single object and start thinking of it as a moving boundary condition. It tells air where to rise. It tells water where to go. It tells humans where passage is possible. It tells ecosystems where temperature and moisture will change. It is a long line of constraints, and constraints create patterns. On the wet eastern slopes, you get cloud formation, heavy rainfall in some zones, landslides that can be frequent. Roads there fight vegetation as much as rock. On the dry western slopes, you get sparse plants, clearer exposures, salt accumulation, dust. Roads there fight water only when it arrives unexpectedly, which is somehow worse. In the high zones, cold shapes everything. Freeze-thaw cracks rock. Snowpack determines water supply. Glaciers, where they still exist, act as reservoirs and erosion agents. And in the human zones, all of that becomes policy, culture, habit. How you store water, how you build, where you plant, when you move herds, where you put your capital city if you must have one. It is all downstream of subduction, even if nobody says it that way. Now, let your attention settle for a moment on the idea of deep time without turning it into poetry. Just take it as an accounting problem. If the Andes rise at something like millimeters per year in some places, that sounds like nothing. But over 1 million years, millimeters become kilometers. Over several million years, a plateau can lift into the sky. A river can cut a canyon. A climate boundary can shift upslope. You are not built to feel that scale, so you experience it as stillness punctuated by sudden events. Earthquakes compress centuries of motion into seconds. Eruptions compress millennia of magma storage into days or hours. Floods compress years of sediment movement into a night. They are the planet's way of being briefly legible. But between those legible moments, the Andes keep doing what they do, quietly. If you were to stand on a ridge in the central Andes, far from towns, you would notice how sound behaves. Wind dominates. Occasionally, a distant rockfall clicks and echoes. Sometimes you hear nothing but your own movement. In that silence, it is easier to believe the landscape is static. But then you look at a scree slope, fresh and unstable. You look at a moraine ridge, loose debris piled by vanished ice. You look at a fault scarp, a step in the ground that looks too straight to be natural, and you remember that it is natural here. Natural just means the earth did it, and it is still doing it. So the long unfinished mountain is not waiting for an ending. It is waiting for more time, and more time is guaranteed. Not for you, of course, for the system. Subduction zones can last tens of millions of years, sometimes longer, until plate motions change. Eventually, maybe the geometry shifts enough that the boundary reorganizes. Maybe a ridge collides. Maybe a microcontinent jams the trench. Maybe subduction slows. Maybe it migrates. But that is another chapter in another time scale. For now, the Andes keep rising where compression thickens the crust. They keep erupting where melt finds pathways. They keep eroding where rivers and glaciers have energy. They keep feeding sediment into basins and oceans. They keep forcing air to rise and drop rain, then leaving deserts in their shadows. And you, standing somewhere along this spine in your mind, can feel the comfort of an indifferent machine. Not kind, not cruel, just consistent. You can almost hear it if you listen in the right way. Not as sound as pattern, a repeating cycle of creation